Hello, this is your teacher, David Garcia, and today we're going to learn how to write the standard form equation of an ellipse from vertices and co-vertices. The first thing we have to do is identify whether we have a horizontal ellipse or a vertical ellipse. Now, in a horizontal ellipse, the vertices are found in here, and the co-vertices are found in here. On a vertical ellipse, the vertices are found in here, and the co-vertices are found in here. Now, if you see the property that relates them is that the vertices on the horizontal ellipse are found on the same vertical coordinate. On the vertical ellipse, the vertices are found on the same horizontal coordinate. So let's take a look at the coordinates that are given in here. The vertices, if you see, are sharing the same vertical coordinate. That means that they are found at the same height, but they are found on different positions along the horizontal. So what we're looking at in here is, here we go, a horizontal ellipse. So if we could give them an orientation, this would be our point 7, -9, and this would be -5, -9. And the co-vertices, they will be found on the same horizontal coordinate. They will be on 1, but they will have different heights, -4 and -14. So this point in here will be, sorry about that, this point in here will be 1, -4, and this point in here will be 1, -14. So now we can discard this ellipse over here. Now, if you pay attention, we already have the coordinates for the center. If what we're looking at and trying to solve is the standard form equation of the ellipse, that means that we're going to require the following variables. Let's complete the equation. All right, this is the standard form equation of the ellipse. There we go. So as you remember, H and K will indicate the center of the ellipse. So if you look at the points in here, we already have that reference because the center will be precisely at this horizontal coordinate. So that means that we already have H equals 1. And we already have the vertical coordinate that is -9. So there we go. K equals -9. Now, if the letter A represents the distance from the center to either point that moves along the horizontal, that means that A, there we go, will be this distance here. In other words, what we're looking for is the change in the horizontal from 1 to 7. Or in other words, 7 minus 1, this is 6. And we already have the value for A. Now the second one, which is B, will be the vertical distance from the center to the covertex. So right about there. This will be B, or in other words, the change in position along the vertical. So that means that from -4 to -9. Or in other words, -4 minus -9, which in this case will be 5. So now we have all the variables needed. So it's just a matter of substituting in the formula. It'll be x minus 1 squared. There we go. Divided by a squared, 6 squared, plus y minus -9 squared over 5 squared, and these will equal 1. Okay. Now, the step that I did before is just to show you how you should substitute it, but if the numbers are easy, you can skip the previous step and just go in here with the 36, and in here you will just go with the 25, and you will be done. And this is the final answer for the problem of how to write the standard form equation of ellipse from vertices and co-vertices. Thank you very much. See you on the next class.